Minitab is the leading global provider of software and services for quality improvement and statistics education. Quality Analysis Results. For more information, visit minitab.com.
Hello, today I'm going to walk you through a one-sample t-test. So let's say that we've randomly sampled 14 observations from a distribution that's assumed to be approximately normal. Our sample mean is computed as 10.3 and the sample standard deviation was 2.6. And for this particular hypothesis test, let's say that the null hypothesis is that the true mean, mu, is equal to 12 units. We're going to test that against an alternative hypothesis that the true mean does not equal 12 units. So how do we proceed? Well, it's a good idea to write down the form of the test statistic. We take the sample mean, x bar, we subtract from it the hypothesized mean, and then we divide it by what we call the standard error, which is the sample standard deviation divided by the square root of the sample size. So if we plug in the numbers, the sample mean was 10.3, our hypothesized mean is 12, and we're going to divide all of that by the standard error, which is 2.6 divided by the square root of 14. And if you do the math on that, then you'll find that this test statistic is actually negative 2.45. So to work out what the p-value would be, it's a good idea to draw this t-distribution. Of course, it's a t-distribution with n-1 degrees of freedom, so it's going to have 13 degrees of freedom. Let's write down negative 2.45, it's going to be about there. And if you work out what the cumulative probability is, all the way from negative infinity to negative 2.45, you'll find that that probability is approximately 1.5%, very close to that. Now keep in mind, of course, the alternative hypothesis for this test is that the mean does not equal 12. So our p-value is going to be 2 times that probability, so the p-value is going to equal roughly 3%. If the p-value is low, the null hypothesis must go. While that p-value is about 3%, that's less than 5%, therefore you would reject the null hypothesis that the mean is equal to 12 in favour of the alternative hypothesis that the mean does not equal 12. So I hope this has been helpful. Of course, if you have any questions on this or anything else, please feel free to email them to me through my website, keithbauer.com.
For more information on statistical methods for quality improvement, visit keithbauer.com.